Hello everyone, I hope you're doing well and welcome back to the Math Chaos. For today, we are going to solve a second order linear differential equation with constant coefficients. And then, first, here to solve this, I will propose that y is equal to e to the rx. Why an exponential function? Because, and as you can see here, its derivative it's the same, okay, and then it helps a lot to solve this kind of differential equations. Then and after that, what we are going to do is to find the first derivative, and then the first derivative it's here. It's too easy because it's only to use the chain rule, and then here the derivative inside of rx it's r times the derivative of the outside part. It implies we have r times Euler to the rx. And then we are going to find the second derivative. The second derivative, it's the same, but in this case we will have r times r Euler to the rx. It's like to say r to the second power times Euler to the rx. Okay, excellent. I will delete this part. Okay, excellent. And after that, we are going to do the substitution here in our equation. It implies we will have okay, the second derivative of y it's r to the second Euler to the rx plus 13 times the first derivative of y it's r Euler, so sorry here, Euler to the Rx plus 30y. Y it's Euler to the Rx equal to 0. Okay, excellent. And as you can see here, we can factorize Euler here, Euler to the Rx times r to the second power plus 13r plus 30 equal to 0. Okay, and as you can see in this equation, we have to find the values of r. And what happened here? Here in the first factor, Euler to the rx, it's impossible to get a 0 here as a value. Then we will use this polynomial expression that we have here. The name of this, okay, and then here I will write it first. I will separate this in our second part. Let me do it better. Okay, excellent. And after that, then we will have this equation. It this is r to the second power, r to the second power plus 30r plus 13 equal, so sorry, r to the second power plus 13r plus 30 equal to 0. The name of this equation is the characteristic equation. Okay, and this characteristic equation will help us to find the values of r. Here we will use a factorization here. As you can see here, it is r plus 3 times r plus 10 equal to 0. Okay, Here it's because 3 plus 10 it's 13. 3 times 10 equal to 30. Okay, excellent. And then the values here of r will be negative 3 and, okay, r's r1 and r2 is equal to negative 10. Okay, why? Because um, as we know in basic algebra, if we have to, okay, both or each factor has to be equal to 0, and after that if we isolate r it's going to be, for example, in the first case it's negative 3. Okay, and then we will have these answers, and after that here, and after that we will write here each answer or each value we found. Okay, y1, the first function, it's going to be Euler to the negative 3x. Okay, and the second r we found it's y2 equal to Euler to the negative 10x. But we need to write the general solution, and this general solution is to have a constant multiplied by the first solution, your negative 3x, plus another constant times Euler to the negative 10x. Okay, excellent. And then here we have our solution of our differential equation. Remember that if you have any question, I'll be able to answer in the comments. And I guess no more. Have an excellent day. Bye bye.